In standard form, we're not allowed to leave a radical in the denominator. So we have to use a process called rationalizing the denominator. To do that, in order to get the radical off the bottom, per se, I need to take this irrational number and make it rational. But I don't want to change the value of the fraction. To keep from changing the value of a fraction, you have to multiply the top and the bottom of the fraction by the same thing, in essence multiplying it by 1. So to rationalize the square root of 3, I'm going to multiply it by the square root of 3. And if I multiply the bottom by the square root of 3, then I have to multiply the top by the square root of 3. When I do this, this creates 2 square root of 3 in my numerator over the square root of 9 in my denominator. Well, the square root of 9 is 3. So this is 2 square root of 3 over 3. So I have taken an irrational number and I have made it rational. Thus, I have rationalized the denominator. In number 20, similar setup. I'm going to multiply the top and the bottom of my fraction by the square root of 5 because I need to make the square root of 5 rational. When I do that, this is the square root of 15 on top because 3 times 5 is 15 over the square root of 25 on the bottom. Well, the square root of 25 is 5, so this is the square root of 15 over 5. Be careful. A very common mistake is that students try to reduce the 15 inside of the radical by the 5 in the denominator. You can't reduce into a radical when you are reducing a fraction. The only way I would be allowed to reduce the 15 is if my 5 were also inside a square root. And number 21, I need to rationalize the cube root of 5, which means I need to make a perfect cube. In number 19, I was making a perfect square because I had a square root. In number 20, I was making a perfect square because I had a square root. In number 21, I need to make a perfect cube, not a perfect square. So I'm going to multiply by the cube root of 5 squared because I need 2 more 5s in order to make a perfect cube. And if I multiply the bottom by 5 squared, cube root of 5 squared, then I have to multiply the top by the cube root of 5 squared. So this will give me 4 times the cube root of 25, because that's 5 squared, over the cube root of 5 cubed, because I have 1 5 and 2 more 5s. When I add those exponents, 1 plus 2, that gives me 5 cubed. Well, the cube root of 5 cubed is just 5. So this is 4 times the cube root of 25 over 5. Again, be careful. You can't reduce this 25 by 5. This 5 is no longer in a cube root. In number 22, I have a fifth root of x squared. So I need to make a perfect fifth. I have 2 x's. I need 3 more in order to take its fifth root. So I'm going to multiply by the fifth root of x cubed on the top and the bottom. When I do that, I have the fifth root of x cubed on top, and on the bottom, I have the fifth root of x squared times x cubed, which is x to the fifth power. The fifth root of x to the fifth power is x. So I have the fifth root of x cubed over x. In number 23, I have 1 over 2 square root of 3x. I just need to rationalize this part of the denominator. So I'm going to multiply the top and the bottom by the square root of 3x. So this gives me the square root of 3x over 2 times the square root of 9x squared. This gives me the square root of 3x over 2 times 3x, because the square root of 9 is 3. The square root of x squared is x. When I multiply the 3x by the 2, this becomes 6x on the bottom. Again, your x's do not cancel, and your 3 over 6 does not reduce, because the 6x on the bottom is no longer in a radical. And number 24, when I rewrite this, this is 1 over the square root of x raised to the 1/3 power. So this is 1 over the cube root of the square root of x. Using the root of a root power, and I don't have a 27 here, so I'm going to use the space below. I multiply my indexes together. So this is 1 over the 6th root of x. 3 times 2 is 6. So I need 5 more x's in order to rationalize. So I'm going to multiply by the 6th root of x to the 5th on the top and the bottom of my fraction. This gives me the 6th root of x to the 5th on top, and the 6th root of x to the 6th on the bottom, because 1 plus 5 is 6. So I have the 6th root of x to the 5th over x. And number 25, remember your quotient property. I can combine these underneath the same radical. So this would be the square root of x cubed over 5xy. So I can reduce this a little bit. This will become the square root of x squared over 5y. Now you can separate them. So this is the square root of x squared over the square root of 5y, and the square root of x squared is x. So I need to rationalize the 5y on the bottom. So I'm going to multiply the top and the bottom by 5y, square root of 5y. This gives me x times the square root of 5y over the square root of 25y squared, which is x times the square root of 5y over 5y. In 26, I'm working with cube roots, but I can reduce what's inside just a little bit. So the 25 over 45 both have a 5 in common. So this is the cube root of 5 over 9x squared. When you separate those apart, this is the cube root of 5 over, I can rewrite 9 as 3 squared. So this is the cube root of 3 squared times x squared. The reason I wanted to rewrite that 9 as 3 squared is because I need you to see I'm working with the cube root, so that means I need 3 3's and I need 3 x's. So I need to multiply the top and the bottom by the cube root of 3x, because I need one more 3 and one more x. So I have the cube root of 5 over the cube root of 3 squared x squared. And I'm going to multiply the top and the bottom by the cube root of 3x. This creates the cube root of 15x on the top and the cube root of 3 cubed x cubed on the bottom. So this simplifies. This is the cube root of 15x over the cube root of 3 cubed is 3, and the cube root of x cubed is x.